Hello everyone, this is Professor Chan from Math 1245 speaking. We're going to be going over our last part for 2.6, which is composite functions and finding domains of them. Now this can be a little bit tricky, so we're going to backtrack and just talk about how to find domains of functions in general. Now, if you remember in the very first lesson, what is a domain? A domain is something that you're trying to find the set of all of your inputs, or in other words, all of your x values. Now, majority of domains that we did back in the first day, they were generally pretty easy. They were generally all real numbers. Okay, but let's talk about specific situations. So I'm going to go over problem one. It says find a domain of this function. Let's take a look at number one. Okay, so the first rule that we want to keep in mind is remember, if I have a variable on my denominator, I'm going to set that equal to 0. Okay? Now, if you don't understand why, it'll make sense later on. So I'm going to set the denominator, or the bottom part, especially if it has an x, I'm going to set that equal to 0. So I have x plus 5 equals 0, and I'm going to solve for x. Right? So I subtract 5 on both sides. So I say x cannot equal to negative 5. Now, there may be a fancy version. Sometimes they'll write it like this. So we say x such that x does not equal to negative 5. Like this, okay? And this vertical bar here, sorry, I know it's a little crooked, but this vertical bar here is called such that. Okay, that's how we pronounce that. This is what's called set builder notation right here, the part that I'm underlining. Okay, and you may see that in your homework. Okay, but if you just say your domain is x does not equal to negative 5, that's fine. Okay, so all we're saying is the following. We're saying is our domain is every x value except for negative 5. Okay, now why is it negative 5? Because if I plug negative 5 into my function, right, notice I have negative 5 plus 5, right, and I have 2 divided by 0. Remember, you cannot divide anything by 0. Okay, so these values don't work because if I plug them in, right, I'm dividing by 0, and that makes it undefined. Okay, let's look at one more example. Let's look at number 3. Okay, so same thing. I'm going to set number 3. I'm going to set the bottom part equal to 0. And I'm going to solve for x. Now remember, what I can do is, just a kind of a quick recap from things that you should know before. Remember, I can do what's called factoring. I have 4 terms. I can do something called grouping. So I split them up into separate groups. I'm going to factor. I'm going to plot on x squared. I have x minus 5. I'm going to plot negative 4. And I have x minus 5. Let me rewrite this out right here. I can factor out an x minus 5. And then x squared minus 4 is factorable into x plus 2, x minus 2. So I'm going to set all these equal to 0. And I have the following here. So I have x equals 5, x equals negative 2, and x equals 2. Now remember, this is what we don't want. So I say this is my final answer. X is everything except for 5, negative 2, and 2. Okay. Okay. Now, what do we do with the radicals? Okay. So let's talk about this right here. If you're taking a square root, you cannot take a square root of a negative number, right? Because it doesn't exist. For a quick recap, remember, if you take a square root of a negative number, it's imaginary, okay? And so we can only have real solutions, we can't have imaginary solutions. Okay? So this is what I'm going to do. How do I determine the domain? Okay? So I'm going to set the inside, and I'm going to inside the radical, I set this equal to 0. I'm going to solve for x. So I'm going to move the negative 84 over. I divide both sides by negative 6. And I have x is equal to 14. Okay? So, and then the thing I want to look at is, now this is where this one's a little tricky because I'm starting off with negative 6x, okay? One of the things I want to see is I want to see which directions it goes, right? So if x is larger than 14, well, it'll end up being negative or positive, okay? So let me kind of give you an example. So if I kind of like use my calculator right here, if I plug in, say, 15 for x, right? So I have 84 minus 6 times 15, right? Notice I get a negative number. So any number above 14, if you notice, gives me a negative number, and I can't take the square root because it'll be imaginary. So my domain this time, this is going to be tricky. I'm going to write it like this. My domain is going to be, and I'm going to do this, x such that x is less than or equal to 14. Now remember, I do include 14 because if I plug 14 in, I'll just get 0, and that's perfectly fine. Okay? Okay? Or you can just say x is less than or equal to 14, right? What does that mean? Because anything number above 14, I have a negative number, so I can't take the square root of that, and that's my final answer. Okay? Okay. You know what? Let's just look at one more example. When I find a domain of number 4, okay? Now, the thing with this one is we have to be a little careful because notice this is a radical, but it's also on the bottom. So that means my denominator cannot be 0 either. So I'm going to set inside my radical, I set that equal to 0, I have x is equal to 3, okay? Now, obviously, 3 doesn't count because if I plug 3 in, right, I'll get 0, and I can't divide by 0, okay? Now, let's talk about, is it going to go less than 3 or greater than 3, okay? And especially if you're dyslexic or you have trouble with order, just try to use your calculator. You're like, well, what happens if I get a smaller number, right? If I have 2, right? Well, 2 is not going to work because if I subtract 3, I get negative, and I don't want a negative number, right? If I do -1, right, that's not going to work either. So in this case, my domain is going to be the following. X such that, for the following, x is going to be greater than 3. I'm not going to include 3 because if I plug in 3, I'll actually get 0, which is on the bottom, okay? And it's greater than because it will remain positive that way. Okay? So that's just how to find domains of regular functions in general. Now let's talk about composites, okay? So we're going to go do some of the same problems we just did in the last video. Make sure that you have notes for that and how you got this, because I'm going to kind of redo this again. Okay, so how do I find composites for, let me scroll down, how do I find a domain of a composite function? Okay, so let's talk about this right here. So we have, right, it says find f of g of x, right? My g of x is -2 over x. My f is 1 over x plus 3, and I want to find a domain of my composite functions, okay? So if you look back up here, right, this is what we did in our last video. Let's understand what's happening for the moment, okay? So we want to make sure the following, right? The idea is there's x to some value such that it plugs into g of x, and then it plugs into f of x. So we want to make sure that my domain includes all the numbers that work, and we want to exclude the numbers that don't work. Okay, so what do I mean by that? Okay, so think of it like the following, right? So the idea is you have like this object, right, and you, I don't know, insert this into this machine called g of x. It spits it out, and then it goes to f of x, and it'll spit something else out. Okay, but when I'm inserting something, maybe there is a situation where if I insert into g of x or f of x, it's going to break the machine, right? So when I say that, I'm talking about mathematically, it's not within my domain, okay? So, and remember, since we're doing f of g of x, it goes into g of x first, okay? So let's talk about what will not work for my domain. So obviously, it has to go through g of x first. So let's look at this right here. So g of x, right, is equal to negative 2 over x. We look at the bottom here, right, and we want to see what it wouldn't work for. And we notice x cannot be 0, right, because if I plug in 0, it becomes undefined. So the thing is, right, I cannot insert 0 because the problem is, right, it doesn't even make it past the first round, which is g of x. Okay, so that is one of my answers. This is generally the easier one of the two. So now I want to think about what may work for g of x, but actually fails for f of x. Okay. Now, this is where it gets a little confusing. Some of you guys are like, well, wouldn't it be negative 3? Because if I plug negative 3 into f of x, it wouldn't work. Now, the thing is, you are partially correct, okay? Because, now, negative 3 actually won't work. Now, why is that, okay? So let me explain this to you. Even though we do know negative 3 doesn't work for f of x, the thing is, it has to go through g of x first, right? So if I plug in negative 3 in for g of x, remember, this negative 3 will not stay negative 3, right? It's going to go into g of x. G of x is going to spit it out, and it's going to be something else, okay? So actually, notice if I plug in negative 3 for g of x, I'm going to get out, it's going to pop out 2/3, and 2/3 is fine. It's going to plug into f of x, okay? So negative 3 actually doesn't work, okay? But you do have the right idea. The idea is we do know that if I plug negative 3 in for f of x, it will break, right? Because I would divide by 0 if I plug in negative 3 for f of x. So I need to think of something such that when I plug into g of x, it turns to negative 3. Okay? There's actually two ways to go about this. Okay? So I'm going to show you two ways. So the first way is we know the outcome we want is negative 3 by the time we hit f of x. So I'm going to do the following, where I'm going to set negative 2 over x be equal to negative 3. And then I'm going to solve for x. So I'm going to cross multiply. This is negative 3x is equal to negative 2 divided by negative 3. And I have x is equal to 2/3. So my answer is actually going to be x such that x cannot equal to 0 and 2/3. Okay? So why 2/3 doesn't work? Because if I plug 2/3, okay, into g of x, it's going to turn into negative 3, okay? And then negative 3 wouldn't work in for f of x, okay? Now, if you're not a huge fan of this way of doing this, okay, you actually do have a slightly easier way, granted, if you want to do the work for it. And that is, if you know your composite function, this would actually work as well, okay? So what you can also do is this. If you know your composite, and remember back in our last video, this was our composite, right? This was our f of g of x. Let me do a different color. Yeah, this was f of g of x. okay, you're going to do the same thing like you did with g of x. You'll just set the bottom part equal to 0, and you have 3x equals 2, and you also get 2/3, okay? So there's actually two ways to get this out the outer part, okay? So one way is you find your composite, which is what we did, right? And then you solve for the bottom part, and then solve for x. Or you want to anticipate what you want it to be equal to for your outside, and then solve for x as well, okay? As you can see, there are pros and cons for each one, okay? So like one thing is like if you don't feel like doing your composites, the one in purple is the one you do. But a lot of times, a lot of people like the green one because it's just easier to kind of set up, right? Just same thing like the one inside, set the bottom equal to 0, and then that's the one that doesn't exist, okay? Let me show you two more examples. Okay. Let's look at... Okay, so let's look at this one right here, right? Which is the one we've done before. Okay, I'm going to erase this just for, but I want to remember what our composite was. You guys should have this in your notes from the last video. Okay, let me just write this out. So the composite that we did when we were solving for f of g of x was 2 over 3x plus 2, okay? Okay. So, how do we find our domains for these, okay? We're going to do the same thing. So, since this is f of g of x, I'm going to set the bottom part equal to 0 for my inside. So, since g of x is equal to 2 over x, I'm going to do the following. I'm going to set the bottom. I'm going to set this equal to 0. And I get x does not equal to 0. Okay. The second part's always a more difficult one. There's two ways we can go about it. We can set the composite equal to 0. So I already know my composite. Set the bottom part equal to 0, solve for x. And this is relatively similar. And I got x is equal to negative 2/3. So my answer is x such that x cannot equal to 0, cannot equal to negative 2/3. Okay? Again, if you don't like this way, let me show this, how to do the second part for you. Remember this. So the idea is, right, the flow chart is x, you plug in some number for g of x, such that that final answer will become f of x. Okay? So let's look. So the idea is we want to work backwards. We notice here that we want negative 3. Right, we want negative 3 to go to f of x because that would kind of break the machine. So I need to think about something about here for g of x such that it's going to result in negative 3. And this is going to be the following. So I'm going to set this equal to 2 over x is equal to negative 3. So I cross multiply. So I have negative 3x equals 2. And I have x is equal to negative 2/3, and that also works. Okay. So I'm anticipating what it should become. I set my first function equal to what the value would be if it breaks f of x. Okay. For the following here. Okay. Now let's look at one more, and then we're going to end this video. So yeah, let's look at this one here. So we had, yeah, this one was f of g of x was equal to x. Okay. So let's take a look at this right here. So f of g of x is equal to x. So remember, you work inside first to look at the domain of g of x. So this one's a little tricky, right? We want to set inside equal to 0. I'm going to add 1. And I have x is equal to 1. My domain, remember, it's not x does not equal to 1. We're going to do, right? Because remember, the stuff inside my radical must be positive. Okay? Now, if you're not sure, plug in a number into x, right? So if I plug in 5, right? 5 minus 1 is 4. That's positive or okay. But if I plug in, say, like 0, 0 minus 1, and that becomes negative. So if we notice, any number below 1 will not count. So I say x is less than or equal to 1. And this is for g of x. Okay? Now, the nice thing for us in this case is we kind of dodged a bullet because my composite is x. So, and this one is all real. Okay? So there's no additional things that we exclude. Okay? So my final answer is going to be my domain x is less than or equal to 1. Okay? Now, if we go the other way, right, we can still do this concept, right? I plug in x such that it becomes g of x, and then such that it turns into f of x, okay? Now, notice what my f of x is this time. It's x squared plus 1. Let's graph x squared plus 1 here. Okay, some of you guys may already know this, but if I graph this, right, what does it look like? Okay? It looks like a parabola, but not only that, okay? Now, again, here's the thing to be very careful, right, with your calculator. Your calculator, it looks like it's cut off, right? That's not true. Your parabola continues to go up, right? Because if I adjust my windows, right, and let's say I make it like 50, right, I can see it's continuously going up. Also, if you notice, it's not just going up, it's also going left and right. So what does that mean? Okay, that means there's actually no x value, okay, that would break f of x. So f of x, right, has a domain that's all real, okay? So what am I saying? So I'm saying when we find our g of x, right, which we know g of x is has a specific domain, it can't be anything below 1. But idea is, it doesn't matter, like let's say if I plug in 1, if I plug in 5, if I plug in 12, right, and so forth, anything that's above 1, it's okay because I plug it in, it's going to calculate for me, right? If I plug in 12, I get 12 squared plus 1, that's 145, right? If I plug in 20, I'll get 401. Even if I plug in like negative 200, right, I'll get 401 as well. So the idea is, it doesn't matter what value I plug in from g of x, it's going to be okay for f of x. So that's why, again, my final answer is domain from x is less than or equal to 1. Okay. So we're going to end here. We're finally done with 2.6. If you have questions, let me know. But the next video, we're going to start with 2.7. That's inverses. Okay. Hope you have a good day, and I'll see you